Okay, let's take a look. So, last place I was at was I made a list, and that list had all the adjacent tiles to the current one. So when I click on this, it created an adjacent list here, and I could see that list down here, but it only updates. Well, the list is made, and that list now gets updated when I'm moving the arrow. Because when I'm moving the arrow is when it's going to recalculate. Oh, wait a minute, I'm floating off here. Is going to be when it recalculates the angles. Only when I'm moving. Okay, that's good. Now let's calculate those angles. How the heck? Okie dokie. What I'm going to do is I'm going to go and take a look at the script here. And what I'm going to do I'm thinking. I'm thinking of maybe putting something, a marker. Should I instantiate a mesh on top of the one that's selected, or change its color? Changing its color and everything like that, I'm gonna have to do a whole refactoring on putting something correct in place. Because right now, I think it's all in the board view. Where's the board view? And it's not efficient. It's kind of gross even. A lot of if statements and stuff like that. Here are the colors here. Selected tile color, movement range, contains unit color, path color, default color. And you see here, no, not during the search. Oh, I gotta take that out now to search stuff. Select tile. So yeah, so if I select the tile, you know, and so I select a tile, it goes into selected tile. Deselected tile, it goes into deselected tile color. But then movement tile show, it just does a lot of like, maybe it's the right way to do it. Show traverse path, the way it gets updated and stuff. Maybe it is the right way to do it. And board view would be the place to put it, I'd say, because that's either that or you have another system. It would need to be a view system. That would be more like UI stuff. Thinking, but board view would make sense because it's a visual aspect. It's a visual feedback of what the system is doing. So I would go in a view system. Now, do I want to change the color of it? Like I do, you know, when I select a tile or when I'm moving it around here. See, all I'm doing is changing the color of that existing mesh. That green is, I'm changing the color of that mesh from green to whatever all the other ones are. All the white ones, transparent ones, are the default color. So when I'm selecting this, I also change all of the ones that are within the range in that list that gets returned to like a darker gray. And it's a color. But when I start moving this over, right, when I start using this thing, which one is being pointed at, I want to highlight the one that's pointed at. Do I want to change the color or do I want to add like aura thing or whatever? And that's more like, not again, final decision. It's just right now, what do I feel like doing? The thing is I have to, if I do the color, I have to, and I'm highlighting this one that I'm pointed at, and I go to here now, I have to say, change this color back and change this color now. And I have to store this one in some way. Maybe not. Maybe not. and to know whether or not, yeah, or all I have to do is just say, hey, you're updating. If you change, just move the existing thing that's on top of this, like the aura, because the aura is an object. And I could move that object and just say, hey, just move that object here now. Like, I don't care where it was before. It changes nothing. Because it's the same one. I'm just moving somewhere else in the world. But right now, what do I want to do? I'm thinking. Because another thing, too, is there's probably a way to do it where I could mix colors together really easily, but sometimes you got a certain color on the board that's representative, like programmer representation of just whatever state that tile is in, like data in a sense. Like right now I have that one selected, like that's like a data point essentially. But I'm like, what if I have something here like the path, and I put something else on top of it, but there's already color there. Like what I'm doing with the unit. You see the unit is green. That's to indicate there's a green there. There's a unit there. When I go over it, it goes blue. I just remove the green, but it's still green. It'd be nice to have a mix of both, right? But if I'm selecting that tile, I override it. But then when I leave, it goes back to green, right? If I had an object on top, not only would I be able to see where that object is by moving that object around, but I would be able to still have the green underneath. So I'd be able to have those two data points visually indicated to me instead of just replacing the color completely. I feel like doing, for now, let me think. I was going to say I feel like doing the object, but I want to think because later I'm also going to want to do multiple, not just one hex, but multiple hexes. And is that going to cause a problem for me if I don't do the color? It would. Well, I'm really thinking. I'm trying to visualize multiple hexes being moved at once. It gets a little, maybe to keep it safe. I'll do colors. Okay. So now I've given myself my goal, which is going to be to highlight the direction that I'm pointing at. But first, I need to know what one I'm pointing at. So in order to do that, I already have all of these. I need to be able to calculate the angle of each one based off of the direction of that arrow. So let's take a look. I'll turn on my second screen again. And see what I have open here already. I might have some stuff from yesterday. How to get directional joystick. Okay. See, what I'm doing right now, let me check something real quick. I might already have it already. I might be doing it already with the camera. Is it in the camera rig? I doubt it. No. No. It's in the battle controller. Joystick movement here. This stuff. This is the actual game object. The rotation of that is being set to target angle, which is here. Target angle is basically, see, I'm taking here the camera rig transform angles of just the Y, right? The rotation value. And what is this? Direction. X and Z. That's a point. Is that a point? I'm turning that into degrees. Radial to degrees. What are these points coming from again? Direction. Direction is of new vector 3. Right? The new vector 3 is the info. Right. It's the actual joystick values coming in. X and Y. X and Y is coming in on those joysticks. Right. And I'm getting a degree with that. I'm turning that into a degree. And then what I'm doing is I'm adding, I forget what A tan2 does. Returns the angle of radians whose tangent is y divided by x. Okay, this is where it gets a little bit, like those little A tan2s and those little math functions are super, super convenient. And although I don't stack a bunch of them at once, I just use them individually there for their convenience. They're a little bit of a pain to really wrap my head around. It's a little bit of trial and error. So, but I think because I'm using this here, which is the direction of the actual, this is the direction I'm pointing. And what I do is I just add the camera to it so it points in the same direction as the camera if I'm pointing at 0. So if I'm pointing at 0, so that means that whatever this is going to be, I already grabbed transfer Euler angles Y. I can grab transfer Euler angles Y on joystick arrow direction now, because it's been set. No, I can't because I have a point. These are not, I'm not using any of the rotation values in those adjacent tiles. I need to be able to calculate the angle from that point to the currently selected point. Thinking. Let me get my whiteboard out. I'm gonna do a guess thing. I'm gonna guess, and I gotta just change my. I'm gonna do a guess, and then I'm gonna go do a Google search, and I'm gonna see if I can find the answer to my guess. But it's an educated guess. Let's see here. Where the hell is my cursor? Oh, there it is. Okay. Delete this. I'm going to just do it like this. This is a hex point. This, what am I doing here? I got one here, one here. How the hell are hexes made again? Boom, boom, wait, boom. Oh yeah, wait. Sorry, 1 second. See, a hex is like this, like this, like this, like this, like this, and like this. Now, I have a hex point here, a hex point here, hex point here, a hex point here, a hex point here, and a hex point here. Now, with that, this arrow could be pointing in any direction, right? It could be pointing anywhere. But I think what I should be doing, although the visual, because I'm adding camera to the actual angle to make it representative of where I'm pointing. Right? So if my camera's looking down and I push up, it's going to point forward up in relation to the camera, which is actually down. But it's because my camera's pointing down. I want it to point in the same direction as the camera. So what I'm doing is I'm adding camera to the actual. But what I should be doing, in order for me to check if I'm pointing down, I need to select down. That's not right what I was thinking. So I need to take this, it's going to be my new angle. I need to associate an angle on each one of these. Now I could hard code it, but I don't want to hard code it. I want to find nearest using math, not say if you're within this range or that range, that's what this is going to be. Because I could do that, but I want to give myself the flexibility of modifying the shape and the rotation of these grids in the future. And doing it math-wise is going to make it so much easier for me to start calculating for multiple hexes at once. Because I'll just be able to reuse those functions. So, back to it. If it's pointing down, right, if it's pointing down, a little bit this way, like, then I have the actual plus the cap giving me this result. And that's going to give me whatever result that's going to give me. And what I need to do is I need to compare that with the actuals of all of these in relation to this. Right, this is 30, this is 90, this is an extra 60, I think, 150, say, and then all the way around. I know that because that's just how hexes are. Hexes have 60 degrees between these two. And this one's only 30 because I'm calculating it from 0 here. But 60 in total would be just 30. So that's why I know how to do it hard code it, but I don't want to hard code it. I want it to check everything around here. Because if in the future, instead of checking 1 out, I might want to start checking 2 out. And if I start checking 2 out, then what happens if I want to start checking this one? It's like halfway, right? If I can automatically generate the angle of this using this point forward and the position of this point and finding this automatically with math is what I need to do. For each one, it's just so much easier. And I can go more and more and more out, right? If for whatever reason I need to like calculate angles further out, that will be a really useful thing to be able to do. Right now I'm just doing it on 1 out. But really at the end of the day, what I need to do is I need to be able to take this tile, this is its 0 point, and say this tile and this tile. Find me, so forward and the 2 points of this thing, and find me this angle. That's what I need to do. And then I'm going to store that value in this tile, in this list, in all the lists for each one. And then the next step after that is, once I get that working, the next step after that is take my arrow wherever it's pointing, and whenever that arrow changes pointing position, recalculate and compare the angle of the arrow with the closest number between 30, 90, 50, and the rest of them, and bring back the one that is the closest. Because if I'm here, if I'm kind of like, well, right now I'm pointing down here, right? And I'm pointing a little bit to this side. So the closest one it would be on right now is 150. So it would check all of them. Say, hey, I'm closest to the angle of 150 right now. I compare and I spit out the result. And the result of that is you're on this tile right now, the 150 tile. And then I could highlight that tile. So, angle, back at it. I need to find the actual angle of the tile itself and the adjacent tile for each of the adjacent tiles. So let me go back to my script here and get my head back into it and think about this. And if I need to, I'll go back on, I'll have to go on Google just to take a look real quick. But you see here, A10-2 is, it gets an angle. Which is really interesting. It gets an angle basically off X and Y of what my joystick is doing. I'm trying to think because I feel like this. See, I know the X and Y position of the adjacent tiles. That's not a problem. Or X and Z position. But it'll do it based off of world space. Does this thing have more like overloads? Where I can give it a source point? Oh, no. Let me check something. Because I feel like it's going to be doing it from a source point of 0, 0, right? If you give it x and y values, like this, right? Source point is 0, 0. You start adding or putting minus x and y or whatever, it's going to start telling you what the angle is based off of this being forward. But I would like for it to tell me the angle. Wait a minute, I'm having a brain. I need it for it to tell me the angle based off of the position of the original. Okay, I think I know what I'm going to do. I need for this to be at 0. This gives me the result of 0. I want 0 to be... Oh, I know what I'm going to do, I think. Let me get the board out again. What the heck? Say the value of this center here is XYZ. Is easy math 10, 5, 20. And the value of this one here, up here, is going to be X, X, Y, X, Y, Z. I don't know which one Z and X is there, but it's going to be up higher here and up higher here. So say that's 15, 5 is the same height, and 25. These are the XYZ values of each of these points. Point 1, point 2, of here and here. World space. Now, which is what I'm kind of calling actual, I guess. So what I need to do is, in order for me to know the angle of this thing, all I need to do is use a tan 2 I have to set this at 0 basically and know the difference of this. So what I would do is I would take P1. I don't want to mix these up. It could be P1 minus P2 or P2 minus P1. One of these two here. Let me think. This one is higher. So I'm going to do P2 minus P1. And that will give me 5, 0, 5. And 505 will give me an angle of something like this. And when I do radian to whatever's, that should give me 30 for this one. Let's try it. Cool. Let's try it indeed. So, I'm just going to move this tablet out of the way so I can have some room for my arms. That's what this is doing. Rad to degrees, I'm just curious if I even would need that. We'll see. So, good. This is just printing. I could keep the printing going on just for now. What I'm going to do is I'm going to do a for each. I already have a for each here, so we'll do it in here. Do I have the selected tile? anywhere. Oh, don't tell me I don't have the selected tile. Selected unit. Dot tile. But I don't necessarily, we'll do it like that for now. Why is it complaining with owner? Really? But I have it here. Okay, I need a place to store it. First things first. And when I get in here, I already cleared data, but I could set the data. Let me think. Actually, I don't need to set it here. I need to set it. Where does that list get made? Adjacent tiles here. List gets made here. So I'm going to go into tile. Thinking. Yeah, I'd like to just calculate those angles once. So what I'm going to do is I'm going to do previous distance direction to next. Use to turn unit before moving into next tile. Oh yeah? Okay, I don't know where I use that. I'll do another one here. This is going to be the angle from selected tile. I know when I expand this, I'm going to need to change it, but I just got this constant self-doubt of like, I know this is going to have to be changed in the future, but angle from selected tile. Why is it? The name angle from selected tile isn't. Oh. Duh. What am I going to store it as? Is it an angle? Let me bring this in the front here. What is it? What are we checking here? MAF F. What does that return in MAF F? Darn it. What does it return? I have no idea what it returns. That's crazy. A10T return value. Will that give me anything? Radians. I don't know that type though. Double A10, double A10-2, double. Return value. The A10 function returns a value in the range of is it it a float? Is radians a type? Let me check something. New class radians, no. Rad? No. Well, I'll set it as float for now. And if it starts complaining about that, I know it's not that. So here's where I do the thing. Okay, so here what I'm doing is I'm getting all of the adjacent tiles. Now, I want to do a for each. Let me go and grab that thing down here I had earlier. For each. When I enter the state. Now, for each of them that I just returned, I want to set the correct direction on them. So what I'm going to do here is I'm just going to go ahead and do, let me just put this here so that I could find my spot again. And what we're going to do is we're going to do, oh yeah, float target angle. It's a float. I could call it target angle. That would work too. I'm just gonna copy this whole thing and I'll work my way through it up here. One tile, angle from selected tile. I think target angle works well. And I'll just put a note here saying this is the returned angle for when a selected tile. This is the return angle of this tile compared to currently selected tile. There we go. And then okay. Oh, I do use the selected unit tile here in a paddle controller. That's okay. So what I want to do is I'm going to make a note. I have it already here. It is P1 is the unit and P2 is the tile. So I want to do P2 minus P1. So the tile minus unit tile is what I want to do. So the angle is going to be let's do that right away. It's going to be a vector 3 and I'll call it vector angle target vector. Call it target vector. And from here, that's going to equal a new vector 3 which is going to be thinking. We said tile minus unit tile. So I'm going to go t dot rotation, t dot transform. Oh shit, tiles don't have transforms. Tile views do. Yeah, that's right. I have to set it to the tile view. Same thing with the unit tile. I have to set the unit tile view. Where are the tile views again? It would be in the board view. Board view is here. Tiles. I got another redundancy here. Tile game objects for some reason. Okay, tiles. Right. Because on the data side, I don't store, see all these tiles and things? I don't store anything that's in the world space. I just store the game data. But these angles is a visual thing. And the visuals have specific angles between each other. So there's data in the visual side of things from that for me to use in order for me to calculate those angles. So I've been kind of using the tile, which is not the tile view, and the view is everything in the game. That's visual. It's represented visually. I have to use those. So, but I have like a redundant equivalent. So I have the data and I have the data view. And if I say, hey, data point number 4, I could just say, hey, give me data point number 4 in the view, and it'll be the same. But the data point number 4 in the view will have extra stuff that I could use. I just need to grab it from there. So where am I now? Vector 3. Right. I need to grab. So for each tile, I want to have a tile view is going to equal, I'll call it TV, is going to equal to, is there such a function as get tile view in the board view? Wait, is this where it is? Yeah. Start, get match, search, clear, get tile. So what I'll do is I'll just do board view, get tile. The board controller here. So let's go into the board view. I'm not sure if that is a system. I don't think it is. But let's try and see what I can do. I'm just looking for a container thing or a game something, game or container. Owner.game, get aspect. I'll just grab all this. Whoops. This will do it. What I'll do here is owner.game. This is a game system, game view system. Dot board. That should be the board view. Dot get tile. And I need to send it a point, which is going to be t dot point. I just want to make sure board is board view. It is. Awesome. All right, cool. So basically I just got it from here. That is awesome. That's the adjacent tile. I also need another tile view. And that tile view is going to be the tile, the unit tile view. Unit tile view. And I'm going to do that by doing this again. By going here. And instead of putting tile.point, I'm going to go do I already have it anywhere? No, I don't. I want to go owner dot current unit. No, it doesn't have that. Unit, selected unit dot tile dot point. Now I have the unit and I have the adjacent tile views. So here, vector3 target vector, I want to do, I was saying I wanted to do the, I think it was tile view minus unit tile view. So what I'll do is I will do, there's a new vector 3. I'm not sure if I could just do, it's a tile view. Tile view dot transform dot rotation minus unit tile view dot transform dot rotation. Is it rotation? No, it's not rotation, it's transform. Or position. That will give me, what is it complaining about? Does not contain instruction to take one argument. Oh, damn. I gotta do XYZ on this, so I gotta do it 3 times. Okay. So the first one's going to be x dot x dot x. See, they're already vector 3, so I thought it would just spit out a vector 3, but I guess I gotta do each individual thing here. So the first one is x, y, and z. There, that worked. Okay. So my target vector is this. Now, target vector x and target vector z, A10. Radians, I don't want to add the camera angle to it. Pretty cool. And then what I'm going to do is I'm going to take the tile I don't think I need any of this. I'll quaternion Euler. No, I don't need any of this. Target angle. No. What I'm going to do now is I'm going to put that float value, because I need to store it in that tile, in all of those adjacent tiles, because I'm going to cycle through each one of those stored values that I'm putting in now and see which one I'm closest to. So what I'm going to do is I'm just going to say now I want to take the tile dot, and we called it, what the hell did we call it again? Target angle? We did call it target angle. And I'm going to equal that to target angle. There we go. Yeah, and it doesn't matter if there was a value already in there. Say you're searching throughout the whole map after like a long session of play, and you start and it's already got a value in there, it will override it here if it's needed. So this is fine. This is fine. I could set it to 0. No, it doesn't matter. Okay. If I do, I could do it on the exit of this state or something. Anyways, good. What I'd like to do now is in this spot over here, just for fun and make sure it's working correctly. Where am I rotating my gear? Yeah, let's do debug log. When I'm rotating an adjacent tile, target angle. Right, let's take a look at what that target angle is. You know, we could put that all on the same line so we'll know which point. Let's go try it out. Stop the playback. Clear that. Let's try it out. All right, let's clear it down here. Let's start moving our cursor. Ooh, wow, eh? Look at that. It works really nice. Remember I was saying 30 degrees? Well, that's 30 degrees. 29.99 on the line. Then 90, then 150. See here? 30, 90, 150. And the other ones that I couldn't wrap my head around real quick is, ooh, minus 150, minus 90, minus 29. I don't know if I want it to be going in that way, and then minuses. I might want it to go 360. It depends. It depends, because when I'm rotating this to here, if I click on this, not that one, 1 second. Minus 143. Okay. So that'll work. I wanted to make sure the value of this rotation, of this arrow, was in the same format as what I was getting here, and it is. Because if we keep an eye on this bit here, and I start rotating around, see here I'm at 90, 90, I'm going up, I'm getting closer to 180, and then it's going to flip at 180 to the minus. There it is, flipped. Instead of going up to 200 and 240 and all the way up to 360, it's just in the minuses. That'll work. That really will work. Except, oh no, that'll work. I think, just thinking. I want to make sure, because if I'm targeting something in the negative here, but I'm close to it here in the positive, I want to make sure that I'm not targeting something. Ooh, what about these ones that are right on? That's the thing. That won't work. Because if I'm targeting one of these, I want this range and this range to work. This range and this range to work. And that is at 180. Now, as far as this thing, the way this works, it might be at 180 or minus 180. But that means that I'm going to have to be on either the left or the right side in the positive or the negative to target this one, if I'm targeting 2 out. So that needs to be converted, but I'm very close to getting this to work. I'd like to get this to work right now. And then what I'll do is I'll convert all those values, knowing that it works. I'll convert all those values to a 360-degree thing. But that does work, which is cool. So now, so here on enter, when we enter the select move target state, and tiles and movement range, onboard short tiles, adjacent tiles results, adjacent tiles. Okay, this is, no, I can keep all that there. That's good. Okay, this is good. Now, we need to start checking. What am I closest to? We're going to do that down in here on movement, on joystick move event. So on the joystick move stuff is each time there's that event coming in is where I need to start checking. Which one am I closest to in that list? How do I do that? Now I'm just going to do a super quick Google search. C# Unity, how to check closer to which is it around? Oh, maybe it's rounding. No, closer to which float? How to check if an object is closer to the bottom side? How can I check as much as close to 0 on a float? How can I check as much as close to 0 on a float? It's a really weird question. Maybe though, that might have it though. If distance is smaller than 61F and get float forward. Okay, what are people saying? Because I don't think this guy knows how to explain a question. Just with his question, you could use math.ceiling. Float result, math.ceiling your value. It will round your result so you could work on the new rounded value. But can I round it to the... If you're wanting near equally, use approximately. var is near equal. Mathf approximately get float forward. If you're wanting whether the value is near to 0, use math absolutes. var is near 0. If you're wanting near equally, but in a wider band, I'm not sure if that is at all what I want, but I'll keep that. There was a couple functions in there that was pretty good that I could search more. Runtime mesh manipulation. Let me try changing my question. Comparing floats. No. How to check if float is closer to A or B. Python. If you're using an earlier version of Python, equivalent function is definition. That's a function. Is close relative. Turn absolute. compare, no, C sharp, compare closest floats. Find nearest number in list of floats. There you go. Hi there, I have a list of floats. That's what I have. I have an extension method which gets nearest number from this array. Okay, let me see what it says. Var closest max value. What is this question? Float closest equals distance closest to 7. Now, if I want to find nearest of number 70, what I want is to modify this function to reset less. Oh, he's got really weird numbers here. What are people saying? Closest to. This IEnumerable float collection float target. Return collection dot order by. Or using the min by extension method from link. I don't know what the hell is a link. I've never even heard of that. You didn't get really positive, definitive answers. It's just 4 upvotes. Closest to this. Why is it IEnumerable? Is this thing IEnumerable? Oh, it is. Ugh. Okay, that might not be necessary. Thinking, because he's kind of, I know there's something in here that he's doing, but his, yeah, let me see. Let me read this here. Whatever he's doing here is not right. People are telling him to do this instead. Using link, I don't know what that is. Link extras, extension method from link extras. What is that? Link extras. A set of extension helper methods to complement the ones from system.link enumerable. Min by, max by. Return the item of a sequence that has the min or max value for a specified key. The winner is with points. Winner name, winner score. Okay. Var the winner equals players dot max by max player score. Okay. But I don't want max or min. I want closest to with a comparison. Distinct unit change. Distinct by, intersect by, intersect by? Intersect means, what is intersect? Allow you to specify a key for equally distinct by, I don't know what that is. Rank by? Okay, that's interesting. These are neat little functions there. I don't need them now, but left outer join, right outer join, fall outer join, to hierarchy, flatten. Well, none of these are what I want. But what about system link? This is extras. What's in system link? C# system dot link. We're getting into that. Executor query. Interfaces, grouping, represent collection of objects, common keys, queryable, parallel executions. Nope. Keep that one open just for a sec. Approximate, compare two floating point values and return true if they are similar. Floating point precision makes comparing floats using the equal operator inaccurate. What? Efficient way to find closest float. Oh, there we go. That's a straight up question. Efficient way to find closest float in an array. I'm having a trouble with this problem and I was wondering if anyone could help me out. I have a float value and I'm trying to find the nearest value out of an array of float values. That's exactly what I'm doing. At the moment I am looking through the array and finding any element that is under a certain threshold. But this seems to be really inefficient way to figure this out. Just wondering, does anyone know a good way to approach this? Order by first. You're not changing the content of the array. You can use a sort binary search method. If the float you're checking is from the array itself, sorting the array based on distance, not from the array itself. He's saying here to what? If you're not changing the content of the array very often, you could use a sort binary search method. Sorting, and this guy here is doing an order by, which sounds like a sort. You're sorting out and you're putting it in the order of. That might be it there. What the heck is all this? Okay, let's read this through here. What are people saying? Are the values, okay, you can use array binary search if it is. Are the values in the array sorted? Binary, if it is, should be pretty quick. Theoretically, they're already sorted from bigger to smaller, I think. I don't know if C# has any native way of filing the array as sorted, but one algorithm of doing this could be this. What does that mean exactly? Finding any element that is under a certain threshold. Yeah, that's a good question. I'd start with the simplest and optimize if necessary. Ordering them. Right. I'm thinking. If I ordered them, or if I checked each individual one, I'd like for there to be a function that would do that for me, but already like but I could go through each one and do current minus angle of the tile. It would return a result. And then I would store those results. And then I would take the smallest one myself. I think that's what I have to do. Darn it, I think I have to build it myself. This works. Get my paper out again. Okie dokie. Weird, why can't I move? Okay, so this works. We know that works, which is cool. Each tile now has an angle. 30, 90, 150, etc. The arrow has an angle. That could be, 127. Arrow angle. So we have arrow angle and tile angle. Let's pretend for a second I am bang on the 31 here. Right, so my arrow angle is like 27.8. And I'm comparing it to the 30 angle. I want to do tile angle minus arrow angle and get a result of whatever this is. 8, 9, I don't know, like 1.2 or something. 2.2. Basically 0. Right? And each time I go through all of these, tile angle minus arrow angle, I'm going to get different values. 20, 157. And then what I want to do what's kind of freaking me out is I don't want to have to reorder that list each and every frame. Because what I would do is I would reorder it from lowest to highest and take the highest each time. And that would be my new, the highest would be the result of, that's the tile that I want to use. I've never really done this reordering of tiles before, so I mean, if it's a float, it's probably easy in a list of floats, but can I do it with a list of tiles? I'm sure it's trivial, but I think that's basically what my situation is right now. I think that's what I'm looking at having to do. Let's try it. I think that's the solution. Tile angle minus arrow angle for each one. And then I could do floats.order by That's weird to me. What is floats.orderBy? Let me look that up a little bit because I can't do floats.orderBy. I need to do it. It's a list of tiles. It's not a list of. Oh, list T. So it could be tiles because it could be anything. Order by float number. Interesting. I have a list that contains instances of Class A. Yes. Class A. Yes. Class A collection equals new list A. Wait, what? Class A. List A collection. Oh, yes. Okay. Yeah, that's his list. I want order the list using collection.orderBy item value. This bit here. Right. This should be working, but the float numbers messes up the ordering. It will produce. So he wants this to be ordered, but it's not. It's doing 1, 1.5, 10, 11, then to 3, then to 4, then to 6, then to 7. Where 10 and 11, these ones, should be over here. This approach works perfectly for if value were int. Oh, interesting. So there's a problem with this being a float. Without creating a new list, collection.sort xy no definitive answer. It's always nice when somebody has like a green check mark next to it with a bunch of upvotes. Well, it's something like this, but what I need to do, this is going to be it. I have to come look at this in a second. I'm going to now see. I'm putting when the adjacent list is being made. I'm setting up the angles here inside of it, and it's called target angle. I could do a target angle delta, target angle actual, or target angle current. Something that will store another float value of the result of its current. Yeah, and that's the one I'm going to use to sort. So let's go back. Whoops. Ready for something. F11. Stop all this nonsense. Okay. Here, F12. So this is the return angle of this tile compared to the current selected tile. Fine. And this one here is going to be the target angle. Let's see here. It will be the target angle. The one that gets updated all the time. Actual target angle. Arrow angle. Tile angle. I think tile angle is better. And then target. Yeah, I'll call this tile angle. And this is the return angle of this tile compared to the current target arrow. tile angle in these other scripts here. Battle controller. Let me just see here. Target angle. I want to make sure this will all make nice and good sense. Target vector. When I'm reading this in the future, I'd probably want this to be tile vector. Tile vector, tile vector. And we're going to call this float. We'll call it tile angle. We'll keep it all consistent. Right? Like that. Right? And then in the tile here, the one that I'm going to be updating is target angle. And how I'm going to be doing that is battle controller, and down here, see, target angle is, I can call it target tile angle. Target angle, target tile angle. I'm going to put a new plus on this one. I'm going to do one of these. Oops. Tile angle. That'll be for my testing later. Good. What's this complaining about? Don't know. Okay. Okay. So what I said we needed to do was arrow angle minus tile angle. And that returns a result. So for each tile in adjacent tiles, I want to do target angle, we're gonna call this not target angle. We're gonna, or t dot tile angle, target tile angle. I think that makes more sense. Tile target angle. It's too similar to the other one I was doing. Oops. See, it was already too similar to target angle up here. So we'll do target tile angle. Wait. Tile angle, no, target tile angle here. Okay. What's the, okay, so T, target tile angle, equals, I forgot the order of it already. Target angle, arrow angle, equals the tile angle, or T dot tile angle, minus why am I having these blanks in my brain here? Arrow angle, target angle. is this? It'll be this here. Dot Y. There. Target tile angle. You know, I think I already have it. Now I'll need to order them. I'll need to order them and choose the one that, what is this? Oh, I was attaching the debugger earlier. Let's see. In my debugger down here. Clear all this noise, go into the state. So right now I'm at 90 degrees. Okay, let's go. I should be closest to tile 1, 0. 1, 0. Adjacent tile target. Adjacent tile angle. Adjacent tile is at 90 as well. Why is it not at 0? They equal the same. Weird. That's not right. It should be at 0. Tile target. Target tile angle equals to tile angle minus arrow. Well, 1 second. Let's try something else. Let's go back into play. I'll go over to this direction here. Right, this is 90 degrees. Oh, I have to select that. Oops. This is 90 degrees. Let's just clear this nice and clear. Why won't it? What's it not updating? Hey, what the heck? Oh, I wasn't. Okay. This one here. See, I should be doing. Let me see something here. Arrow parent. See, it's 90. Oh, but I'm using this one. I'm not using arrow parent. I need to be minusing arrow parent. Why is what the hell? Where am I? Okay, 1 second. Here. But I'm setting it here though. Weird. What do I have up here? Joystick transform. Boom. I think that's what it is. I don't know how it didn't even give me an error. Let's try that and see. Nope, it's still not. See the 90 here? All these values are the same. They shouldn't be the same. They're not exactly the same, which is kind of weird. I don't understand why, but 90 here should be minus this value. But it's giving me 89. Isn't that weird? Am I going crazy? This is a float, and this is a quaternion. Oh. 2 rads, maybe? Equals 1 second. Math F to rads. Target angle. It's one of these. It's one of these. It's something about quaternion and Euler's and stuff, and I don't do much of that, so I just need to know what's going on here. It's quaternion. Owner. Quaternion Euler. So what can I do? Minus. I mean, this is just a shot in the dark. I really have no idea what I'm doing. But let's try something. No, I didn't want to do that. Why not? Quaternion that stores a rotation of the transform. Yeah, what's it complaining about? Minus cannot be applied to operative type float and quaternion. Math to rads. Euler angles. Rad to degrees. Fuck, I don't know. Transform dot Euler angles, maybe? I don't know. Let's try that. I'm guessing. I know the result needs to be 0. So whatever, when I have it at 0, I will have found what I wanted. Yeah, I got it. Here, 90. Whoops, here. Wait, let me stop touching it. 90. Going 90 degrees. I'm at 0 now. So I know that of all of these tiles, the closest one at 0 is the one I'm pointing at. 1, 0. The other ones, I should be closer to 1 minus 1 and 0 and 1. So 59 is 1 minus 1. And this other one here, 59, 0, 1. This one. And then the other ones here are further away because I'm pointing here. But this one is at 0. It's the closest one to 0, so that's the one I'm pointing at. Good. Good, 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 good. Nice one. Which one is at 0 now? One of these need to be at 0. None is, wait, clear? Oops. Whoa, I'm in the 290 ranges here now. Ooh, that's not what I wanted. Let's go to 1, 1. Good. Good. This one here. Good, good. This one here. Good. Now when I go here to -1, 1. Whoa. The smallest one I have now is this one, which is 0 and 1. Still this one. So this is not right, and it has to do with how the that problem I was talking about earlier. It not doing 360. It's doing something else. It's doing minus. Which is actually, even if it was 360, 360 is up here. Fuck, that's not even gonna work, is it? Don't tell me I really got to get into this whole rotation stuff. Because even if it was at 360, see earlier I was worried about sticking out here and choosing between this one. If I was going 2 out for a check. But if I'm doing 360, the problem is either down here at 180 or up here 360. Because on this side I'm at 360 and on this side I'm at 0. And this tile that I'm on right now, right here, is going to be one or the other, 360 or 0. See, if it's at 360, then if I'm on this side at 0, I'm actually the furthest away from this tile, because it has to go all the way around here to get that. And the opposite is true as well. If it's at 0, if this tile's at 0, I'm a little bit on this side. And I'm 360 away. I'm not at 0 or 0.02 away. I'm far away from that. Same as down here. Let me try something. I could rotate this and keep going up. See how the value keeps going up? It doesn't go to minus. If I divide that by 360, let's try something. I'm at 720 right now. Right? 720 divided by 360, 2. It's pretty darn close. Thinking. See, if I was at 360 divided by 360, right, 1. I'm on it. If I'm at 180 divided by 360, 0.5, I'm not on it. But I got a lower value. Problem is like, let's say for example I'm at 30, right? I'm right here. Let me bring it back down. I'm at 30. This is going to be 0. This needs to also be at 0, but I'm actually at 392 right now. This is a scratcher, a head scratcher. I don't know because I'm not used to dealing with rotations. Maybe I should do a form question. Just clear it, make it nice and clear what I'm trying to do. I know someone knows the answer to this. Rotations is one of those things that people have a hard time with. It tends to break people's brains a little bit, but supposedly it's simple. You just need to put in the time to get to understand it. Let's take a look. Quaternions versus Euler.
In a moment, I'll point you to a separate website hosting a short sequence of what we're calling explorable videos. It was done in collaboration with Ben Eder, who some of you may know as that guy who runs the Excellent Computer Engineering channel. And if you don't know who he is, viewers of this channel would certainly enjoy the content of his, so do check it out. This collaboration was something a little different though, for both of us. And all of the web development that made these explorable videos possible is completely thanks to Ben. I don't want to say too much about it here, it's really something you have to experience for yourself. Certainly one of the coolest projects I've had the pleasure of working on. Before that though, if you can contain your excitement, I want to use this video as a chance to tee things up with a little bit of surrounding context. So, to set the stage, last video I described quaternions, a certain four-dimensional number system that the 19th century versions of Wolverine and the Old Man from Home Alone called evil for how convoluted it seemed at the time. And perhaps you too are wondering why on earth anyone would bother with such an alien-seeming number system. Well, one of the big reasons, especially for programmers, is that they give a really nice way for describing 3D orientation, which is not susceptible to the bugs and edge cases of other methods. I mean, they're interesting mathematically for a lot of reasons, but this application for computer graphics and robotics and virtual reality and anything involving 3D orientation is probably the biggest use case for quaternions. To take one example, a friend of mine who used to work at Apple, Andy Matuszczak, delighted in telling me about shipping code to hundreds of millions of devices that uses quaternions to track the phone's model for how it's oriented in space. That's right, your phone almost certainly has software running somewhere inside of it that relies on quaternions. The thing is, there are other ways to think about computing rotations, many of which are way simpler to think about than quaternions. For example, any of you familiar with linear algebra will know that 3x3 matrices can really nicely describe 3D transformations. And a common way that many programmers think about constructing a rotation matrix for a desired orientation is to imagine rotating an object around three easy-to-think-about axes, where the relevant angles for these rotations are commonly called Euler angles. And this mostly works, but one big problem is that it's vulnerable to something called gimbal lock, where when two of your axes of rotation get lined up, you lose a degree of freedom. And it can also cause difficulties and ambiguities when trying to interpolate between two separate orientations. If you're curious for more of the details, there are many great sources online for learning about Euler angles and gimbal lock, and I've left links in the description to a few of them. Not only do quaternions avoid issues like gimbal lock, they give a really seamless way to interpolate between two three-dimensional orientations, one which lacks the ambiguities of Euler angles, and which avoids the issues of numerical precision and normalization that arise in trying to interpolate between two rotation matrices. To warm up to the idea of how multiplication in some higher dimensional number system might be used to compute rotations, take a moment to remember how it is that complex numbers give a slick method for computing 2D rotations. Specifically, let's say you have some point in two-dimensional space, like 4, 1, and you want to know the new coordinates you'd get if you rotate this point 30 degrees around the origin. Complex numbers give sort of a snazzy way to do this. You take the complex number that's 30 degrees off the horizontal with magnitude 1, cosine 30 degrees plus sine of 30 degrees times I, and then you just multiply this by your point, represented as a complex number. The only rule you need to know to carry out this computation is that I squared equals -1. And then, in what might feel like a bit of black magic to those first learning it, carrying out this product from that one simple rule gives the coordinates of a new point, the point rotated 30 degrees from the original. Using quaternions to describe 3D rotations is similar, though the look and feel is slightly different. Let's say you want to rotate some angle about some axis. You first define that axis with a unit vector, which we'll write as having I, j, and k components, normalized so that the sum of the squares of those components is 1. Similar to the case of complex numbers, you use the angle to construct a quaternion by taking cosine of that angle as the real part, plus sine of that angle times an imaginary part. Except this time, the imaginary part has 3 components, the coordinates of our axis of rotation. Well, actually, you take half of the angle, which might feel totally arbitrary, but hopefully that's going to make some sense by the end of this whole experience. Now let's say you have some 3D point, which we'll write with I, j, k components, and you want to know the coordinates that you'd get when you rotate this point by your specified angle around your specified axis. What you do is not just a single quaternion product, but a sort of quaternion sandwich, where you multiply by q from the left and the inverse of q from the right. If you know the rules for how I, j, and k multiply...
So freaking lost right now, but I think he was saying the Euler angles, which is the simple way of seeing it with 3 numbers, causes gimbal lock, right? And gimbal lock is problematic, and I think also he was talking about how the limitations when you get to the extremes using Euler, and he's saying quaternions avoid all this, what he's showing on screen right now. So he's kind of showing how to do it with quaternions, but I'm pretty sure there's probably a way to do it using functions.
Multiply amongst themselves.
So I wouldn't have to know how to put all of this together.
You can carry out these 2 products by expanding everything out, or more realistically by having a computer do it for you. And, in what might feel like a bit of black magic, this big computation will return for you the rotated version of the point. Our goal is to break this down and visualize what's happening with each of these 2 products. I'll review the method for thinking about quaternion multiplication described last video, and explain why half the angle is used, and why you would multiply from the right by the inverse. On the screen now and at the top of the description, you'll find a link to eater.net/quaternions, which is where Ben set up the explorable video tutorial, where I explain what's going on with this rotation computation. It's just really cool. Eater did something awesome here. So,
okay, cool. Let's try Unity C#. Rotating object using quaternions.
In Unity, a transform's rotation is stored as a quaternion. These work similarly to vectors, but have 4 components: x, y, z, and w. These components are interdependent and work together to define any rotations that an object might need. One of the most important things to remember about dealing with quaternions is that since the x, y, z, and w components work together, you should never adjust them individually. Thankfully, Unity has many built-in functions to make managing quaternions easy. The system for managing rotations that
exactly what I want to know.
You are probably already familiar with is called Euler angles. The rotation values shown in the inspector use this system as it is slightly easier to understand. Euler angle rotation is based on a rotation around each of the x, y, and z axes. You might be wondering why Unity uses quaternions if Euler angles are easier to understand, especially since Unity converts the quaternions to Euler angles for the inspector. Suffice to say that Euler angles are subject to something called gimbal lock, which can prevent incremental rotations from working correctly. Luckily, since Unity stores rotations as quaternions, which are not subject to gimbal lock, we do not experience this problem. Let's take a look at some of the functionality that is available through the quaternion class. We will start with the look rotation function. Here we have a scene set up with a character and an orb. The character has a script called lookAtScript attached to it. The orb has a script called motionScript attached to it. The motion script simply moves the object side to side based on the horizontal input axis. The lookout script has a public field for a target transform, and in the update function, we will be using look rotation to cause the object to rotate to face the target. The look rotation function takes in a vector 3. It returns a quaternion rotation aligned with the vector 3 passed in. By calculating the relative vector between the object and the target, we can make the object's z-axis point towards the target. This works in a similar way to transform.lookAt, but utilizing quaternions sets the rotation explicitly. It is also worth noting that we can pass in a second vector 3 to the function. This vector 3 tells the function which direction is considered up. Back in the Unity editor, let's run our scene. We can see that no matter where we move the orb, the character turns to face it. The next function we want to look at is the slurp function. Slurp is short for spherical interpolation. It is very similar to the lerp function, which stands for linear interpolation. The big difference between the two is that lerp will interpolate evenly between two quaternions, while slurp will interpolate on a curve. The result is that lerp will provide an even change over time, while slurp will start and end slower and be faster in the middle. We have here a scene with another character and orb. The character has no scripts attached to it. The orb has a gravity script attached to it. This scene will utilize slurp and some forward movement to achieve a gravity orbit effect. In the gravity script, we have a setup similar to the lookAt script from before. Again, we have a public field for a target transform. We are also calculating the relative vector between the object and the target, though this time we are adding an offset to account for the orb's height. We are also calculating the look rotation like before, except we are not storing it in the rotation of the object's transform this time. Instead, we are storing it in a quaternion variable named rotation. We are then storing the local rotation of the object in a quaternion variable named current. After that, we are using the slurp function to slowly turn the object.
That's interesting. So quaternion is a type. And to remember also is you could probably do quaternion.x, quaternion.y, quaternion.z, and w, but you never want to do and modify any of those individually because they all work together in some sort of balance. So I can't just adjust the y value and expect it to go up in y because they all balance out in ways that are, something special. So this is cool because here he's storing two different values. Like in a way, kind of like in my mind, I kind of see it as, hey, instead of using a float, use a quaternion. Float, I was storing an individual value I was trying to get. But quaternion,
Object to face the target.
Here he's doing basically a smooth in and a smooth out between the two positions. So current, rotation, and over how much time.
The slurp function reads.
That's really interesting. So if it works like that, I could probably do quaternion minus quaternion. I think.
It's in the current rotation, the end result rotation, and the speed it should interpolate or turn.
Let me just check something. See, I'm setting the rotation here to quaternions are used to represent rotations. Returns a rotation that rotates z degrees around the z-axis. Yeah, so I'm sending a quaternion to the rotation. I'm manipulating an individual value as if it was a Euler, but I am converting that into a quaternion before sending it back into my rotation value. I shouldn't be using this final value at all at any time, the joystick arrow direction. See here, I use it because this is like this weird converted thing that is subject to gimbal locks. This, on the other hand, or sorry, this quaternion stuff is not. The target angle is a float, but I could make it a quaternion. And the angle itself in that quaternion could be just this specific Euler axis, which it is. I'm just doing it on two lines. But I mean, I could just do like I could do this. Let's see if this works. I'm going to copy this line. Copy this, do this. I'm going to just mute this one. Turn this into a quaternion. Whoops. Quaternion. Right? Target angle. Quaternion. And it's going to be target angle, quaternion. Right? And I'm going to just put this here. Right? This entire thing. It's going to be this. And then this target angle is that. This is the exact same thing. But target angle is now a quaternion. And target angle is absolute plus camera. Transform.EulerAngles.y. I'm going to just make sure that it still works. It should, though. I don't want to start building more on that. And yeah, it works just fine. Okay. So really what I should be doing in these tile bits here is not public floats. I could do public quaternions. These are tiles. Shit. It's a Unity engine thing. I can't put these in this. have to put them in the tile views. I should take this out here too, because that could have been a mistake. It was letting me do it because this is there, but if I took this out, which it shouldn't be there, see? I shouldn't even have hide an inspector there. Yeah, vector 3. That's why I'm leaving it there, because I need a vector 3. I'm supposed to be using numerics or something like that. I don't remember what it's called. But in the non-Unity version. But it defaults to the Unity version. These, I can't do this. I have to put it in tile view. I'll just refactor it to go into tile view. That's okay. Let me just look it up here. What do I have in tile view? Ooh, a lot of stuff. Unit view, Text Mesh Pro. There we go. I just broke a lot of stuff by doing that. I gotta go in and fix it. Because Tile used to have these and now it doesn't. So board controller is gonna start saying, hey, why don't I have... I should have a nice little function to like say, hey, this is the tile, but I want the equivalent tile view, which I think I kind of do. Joystick, what are we in here? We have... all these work fine. All these work fine. Here it's when I'm trying to do... oh, I'm trying to populate the tile view. With those values. Yeah, that's what I'm... so what I'm doing here is I just need to... for each tile in T... I already do it up here. I'm just looking. On enter, I think I do it. Where is it? Here. On enter. Yeah, so when I'm gonna, so already on enter there's an error here. Tile angle is now quaternion. I'll go ahead and set that up as a quaternion. And here's target angle here. Just gonna grab this part here, go back up here. Just gonna put this down here as a note for myself. What am I doing here? I'm grabbing the vector of my controller. Is that what I'm doing? No, I'm grabbing, I forget what I'm doing here. Oh yeah, I'm setting up the tile vector, tile vector. Interesting. doing. Setting it up as a quaternion. But I do need to be able to minus this and minus that later. So yeah. Let's do, this is what I want. Math F to radians though. This one I'm not sure. Cannot, right. But what does math F to rad to degrees do? I don't think I need that. But I'm not 100% sure. Why am I deleting that? I'm going to take this part. I am converting it to Euler. Hope there's a way to I don't want to convert it to Euler though. Fuck, I don't know what I'm doing. Hold on. 90. This is going to be 90. I'm thinking how it was storing the 90 degree before. That's going to be 90, right? Oh, it's a position. It's a vector 3 position. True. That spits out 2 position vector direction. Maybe I shouldn't be touching this. Tile angle. Let me check math to Ayton. Math F Ayton to quaternion. Okay, so people are looking it up with no answers. Whoa. Look, I'm not getting into that. That gives me an angle. Can I store C#? Storing angle in quaternion. I don't know if that's going to pull anything up. How do I convert a quaternion to an angle? Normalized. Okay, and the rotation angle is C# Unity, can I subtract quaternions? This is exactly the same. You divide complex numbers. Unity does not implement the division operator, so you have to multiply it manually in the inverse. Just to clear up some confusion. Yes, usually you could subtract, multiply, and divide quaternions. However, we only use quaternions to represent relations. Add or subtract two quaternion rotations. Hi, I'm trying to instantiate. Okay, multiplying should give you the results you want. Transform.rotation times quaternion.Euler. Peter G's. I'm not sure why Peter G's response was voted as correct or voted up. It's simply wrong, okay? Multiplying a quaternion by a vector returns another vector. What is he doing? I'm trying to instantiate a shot in front of my ship. Shot, okay. But with a custom rotation relative to my ship's local coordinates. Okay, so I tried this. Instantiate shot prefab transform pivot vector yeah, transform point okay, transform rotation plus, okay, but I get this error. Operator plus cannot be used with the left hand side. Okay, but that's right. So he's taking this Euler and he's adding he's putting Euler on there, but he's getting what? Operator plus cannot be used with a left-hand side of type. Left-hand side type Unity quaternion and a right-hand side of Unity engine quaternion. It's the same thing. So it says I can't add two quaternions. What's the best way to solve this problem? Multiplying should give you the result you want. That is weird. He doesn't want to multiply. That is a dumb answer. What is he saying here? That is weird. Why would that be voted up? Multiplying by vector returns another vector. And the vector you multiply by should be a direction vector, representing a direction from the origin, not a set of floats representing Euler angles in degrees. The result of that multiply operation is that, okay, so he's just saying this is dumb. Is he showing him how to do it? The result of that multiply operation is that direction vector rotated by a quaternion. In order to add two quaternion rotations correctly, you multiply them. Quaternion, new rotation equals transform.rotation times other transform.rotation. To subtract, you need to multiply by the inverse. Rotate back to the starting position. Transform.rotation equals new rotation times oh, so he's saying alternatively, you could use Euler angles and simply add or subtract the values, then convert the result to quaternion. Okay, there's a subtle something here in that you can't add or subtract quaternions. You can add, subtract Eulers. And then if you want to store them as quaternions, you can. If you want to add quaternions, you need to multiply them. In order to add quaternion rotations correctly, you multiply them. And to subtract you need to multiply by the inverse. Okay. That's the weird shit. But when you get used to it, they say it's pretty easy. But there's basically two types. There's quaternion types and there's Euler types. Euler types are your standard XYZ. Quaternions are different. They contain an additional W value. You cannot modify individually any one of those four, and they avoid gimbal, which is important. So, if this is not R&D, I don't know what is. Whoops, that's not what I wanted to do. I should go eat something. So I can convert to okay, I got errors. Let me go fix those errors real quick. But I think I could use quaternions. That's fine. My checks could be done. My problem is those freaking gimbals. 360 and 180, depending on how I end up doing it. Is there a way to know to order a list? Or if I convert the quaternion to Euler. No, because that's the problem. Is when I go into Euler and I do my check in Euler. See, I don't know if I could order a list. I could order a list of floats to know which one I'm closest to. But can I order a list of quaternions? Ooh, that sounds messy and not even possible. I was going to go into script and I have to fix that thing real quick because I went into the tile view, and when I do that I'm going to forget what I'm thinking about now. I'd like to find some kind of solution to try. C#. Can I order a list of quaternions? You don't have to use complex formula in order to read a value from a quaternion. Unity already did it for you. The easiest way to read the Euler angle of a quaternion is like this. Euler angles. You can read each rotation easily. Yeah. What is he trying to do? I want to read the following values from Unity Quaternion. If X rotation pitch is 180, alternatively 0. If Y position roll is 180, alternatively 0. What is the most performant formula to get the Z rotation? I found this formula online to get the Z axis. Does it for you. Formula I posted was a conversion. Who's writing these? This person that wrote this one was who? Martin. And then Martin was writing again. The formula I posted was a conversion from quaternion to angle. Axis. What I needed was quaternion to Euler angles. I realized I didn't need X and Y angles anyway. Found some code online and shipped it to suit my needs. This converts only the Z-axis to radians. 1.3, that's a lot, isn't it? 10 iterations. Seems like a lot. Public double get Z angle. There's no clear pattern to just distinguish if the x and y angles were 0. But there is a code snippet here shows how to retrieve all of them in radians. This is from 2016. I was so close. I'm going to pause this for a bit. I'm going to go eat something.